Ladies and gentlemen, it's that time. It's time for another episode of Matthew Thompson, famous YouTuber. And today I am bringing you what is probably my most special video to date, my most important video to date, my most educational video to date, and really what's going to be a cornerstone video of this channel and society for years to come. Before we get going, you know the drill. This is Matthew Thompson, famous YouTuber. If you're not already subscribed, please do so that way we can hit 100 subscribers and I can do some sort of special video for you, even though this is the most special video we'll ever do on this channel. It's just me here in my kitchen as per usual. I got my LaCroix, and today I am bringing you a forensic evaluation of a gingerbread house. Now, many of you know me as a famous YouTuber, which that is who I am, but I also happen to be a licensed professional engineer, specifically in the field of civil engineering. I also happen to be a licensed residential builder. So when it comes to residential homes, I know a thing or two when it comes to the structural side. And just this time of year, with everything that's going on, the holiday season, a tradition that many of us partake in is building gingerbread homes. And the thought occurred to me is that we have a very concerning shortage of homes right now. It's no mystery to you, to me, anyone watching this video, that housing prices are astronomical and they're out of control. So a question I thought to myself is, can we solve the housing crisis through gingerbread homes? Typical kit like this is about $40, $20 depending on where on Amazon you buy them, or your local grocer. That includes also additional candy, accessories / claddings you'll need to buy. But all in all, compared to typical American home, which is probably around $300,000 right now, it's not half bad. So we do need to make sure, though, that any sort of gingerbread home is structurally sound to occupy in terms of other things like plumbing, HVAC, electrical. I am not authorized to provide opinions on those things, and thus you would have to contact a qualified professional in those fields for further information after this video is over. I'm just here looking at the gingerbread home from a structural perspective. Now, I went and built this. This is what we could consider a typical stock gingerbread home. You can get it anywhere. And so my purpose of this is to give you just an evaluation of it from a structural perspective and from an exterior cladding perspective to help you understand as to what this exactly is and what conclusions we can draw from that. So starting off, we'll just kind of go through our general observations of the gingerbread house. So starting off, it appears that we have a single-story home. It's clad with a Sour Patch Kid veneer at the base of the elevations, and then a, maybe not cementitious, but a sticky sort of adhesive sealant type material across the remainder of the elevations. There's ornamental gumdrops on the front and rear of the structure. The roof of the structure is covered with a similar paste-like cementitious type material with an M&M based ballast on top of it. The foundation of the structure appears to be a piece of cardboard. Windows on the home appear to have decorative candy trim around them, varying types and profiles. You have differing ones on the front, along with the side and rear elevations. Structural elements of the building appear to be constructed of, in fact, gingerbread. It appears that it comes in 6 pieces in total, that being the side pieces, the front pieces, or front and back piece, and then the roof pieces, and then all these other claddings are put on top of these structural elements. Starting off with the elevations, as I mentioned, we have the Sour Patch veneer. Essentially, these appear to be Sour Patch candies that are attached to the cementitious coating on the home. Um, these don't seem to serve any other purpose outside of a decorative sort of veneer. I don't see much um, purpose in these in terms of water shedding ability. I don't think they have much of a insulating property to them either. So all in all, they do add a maybe a nice decorative touch to the home. So that is important as well. I'm not a qualified architect, and so this is more of an architectural feature, but something to note. In terms of the windows of the structure, I do have some concerns about these window trims. There appears to be a lot of gaps in them around the edges, and windows are notorious for being a spot where water can easily enter into the home. At this, I don't know the word. I'm not working right now, so I can't give you the exact term, but water getting into the home at these locations could be bad. So that's another concern that I would have. It appears at the base of the elevations, they've put this different but similar sort of binder material. Maybe we'll just call it the frosting. And that appears to be what is acting as the waterproofing method, as well as the sealants around the base of the elevation. Do have some concerns about that. Main roof of this structure is a gable. Just kind of by the looks of it, I would say maybe pitched at about 812, 912, but that's just me firing from the hip right there. I'd have to get my pitch gauge from my car to give you a more precise measurement on that, and I don't think I'm going to go out and get that. That would require me to pause this video. But yeah, so that's just kind of the general observations I have around the exterior and the elevations of this structure. The gumdrops, I guess, are a nice ornamental touch, but they don't really do anything. It looks like the primary water shedding element of this would be the frosting material that's all along the elevations. I suppose it could be tested as to whether or not this is water soluble, or if it is in fact going to work and prevent water from getting into your home. I would assume it provides minimal insulating value, unless if you caked a whole lot of it on there, which is possible. This does raise concerns if this is used in a northern climate, and I think the general theme around gingerbread houses is that they're in snowy climates. So that's a red flag too that kind of comes up as I'm taking a look at this. So now, kind of moving on to the roof. As I mentioned, this is a gable pitched maybe at approximately 812. You might be looking at this and think to yourself, "Oh, this is a typical shingled roof, and the M&Ms act as the water shedding shingles." That would not be the case with this one. If you look closely, the M&Ms are not actually layered on top of each other at all. They're just kind of sitting in this frosting material. So those don't really serve much of a purpose in terms of water shedding. They do maybe look kind of cool, which might be another architectural feature, but we're not architects here, we're structural engineers and builders. So that's kind of a red flag for me as I'm taking a look at this. They could kind of serve as maybe like a ballasting thing. If you go onto some flat roofs, sometimes there'll be a gravel ballast to help prevent deterioration of whatever's underneath. Maybe these M&Ms could serve in that purpose, so maybe they do serve a structural function. They do likely, though, greatly increase the dead load on the roof, which we'll get to the structural evaluation of this later. That is a concern to me, that we're adding a large amount of dead load to the roof, but what can you do? Outside of that, I don't know if there's much to say on the roof. The ridge of the structure, where the two panels of the gingerbread meet, just presents a continuous bead of the frosty material, the frosting material. So that's what prevents water from getting in at the ridge. Moving to the foundation, as I said, it is a piece of cardboard. If I had to take a guess, it's approximately, I mean, I don't know if I'd even say that's an 1/8 inch thick. We might be looking at 1/16 inch thick. It appears to have a um, some sort of white covering, a laminate on top of it, which that does serve aesthetically more pleasing as a brown cardboard, and I assume it has a bit more of a moisture wicking property than your typical cardboard, so maybe some usefulness in terms of water shedding with that. The base of it, we're gonna tip up the corner here, is your typical cardboard. That is a concern because that's going to be the portion of your foundation that's coming in contact with the ground. And as we know, the ground gets wet, and so I would have liked to have seen the same laminate on the top, on the bottom of this gingerbread house in order to maximize the water shedding ability of it. I am also concerned about the thinness of this foundation in a freezing climate. This is going to be very prone to frost heave, and so I think that they're going to run into that problem very early on during the life of this home. But yeah, kind of continuing with that, just in terms of freeze thaw issues, I do have concerns about gingerbread as the primary structural material. I'm no expert, but I have a feeling that freezing and thawing of gingerbread is going to make it prone to cracking, which would provide multiple potential sources of moisture intrusion into the home. I'm also concerned about freeze thaw for the frosting material. When it gets wet, is it going to be able to hold up over a prolonged period of time? We have to keep in mind that this frosting is not only serving as the exterior kind of sealant around the structure, it's also serving as the primary adhesive of the structure. So it's really pulling most of the weight in terms of the structural aspect of this gingerbread house. All these fancy things you see on it, like the M&Ms, our Sour Patch Kids, our little candy pieces, those really don't serve much of a structural purpose. Those are all architectural elements. So what we're primarily looking at is our pieces of gingerbread and the frosting, both of which I think are not going to hold up well in terms of a cold climate such as Michigan, where I'm at. Outside of that, there are some structural issues that I see with this as well. As I mentioned, we'll start kind of from the top down. The roof has a lot of dead load to it already. There's a thick layer of frosting on it, along with the M&Ms that are on the top of it as well. That's a concern. When I think about what's going to happen when snow load gets on it, essentially what's going to happen is that these are going to start to push down, and they may also push outward. The problem with that is that there's no actual connecting structural members on the inside to make sure that these walls don't fall apart outside of the adhesive, that being the frosting at the corners. So I think that as we get snow on the structure, you're going to start to see these members start to separate from each other. Even worse yet, if you start to get an unbalanced snow load, so say we have our winter storm coming out of this direction and it comes onto our roof over here, eventually, or will come onto our roof evenly, eventually wind will put more snow on this side, and you can see some separation maybe up here at the top. These are just a couple of things that I'm seeing with the roof that would be a concern to me. I do also have questions about the brittleness of the gingerbread. Gingerbread I wouldn't expect to be a strong material either in tension or compression. You have to keep in mind this gingerbread piece is spanning from here to here with no additional support member in between. So that means you're going to get a lot of stress here kind of at the center of the gingerbread from all this dead loading and the snow loading. You could start to see some cracks in the middle of the gingerbread from said loading. Outside of that, I think that does cover all the structural issues with the roof, at least the ones that come to mind for now. Going further, we have the walls. With the walls, we do have the dead loading that would, or not dead loading, dead loading and snow loading that would come from the roof pushing down onto these walls. That's going to put these walls in compression, but I'm more worried about tensile forces on these walls than compression. I think it'll do better in compression, but not a ton of bending stress either outside of wind loading that would come in. Hopefully this is in an area with mature vegetation coverage that could provide some protection to it from wind. Outside of that, I do have concerns on the elevations as well, as I've mentioned multiple times, these joints right here. As wind starts to push on this wall, say right here, essentially what's going to happen is that force is going to kind of get transferred into these walls, but we don't have a very robust structural connection, so what you could see is that this wall just pushes inward. If this wall pushes inward, you have all sorts of problems. And I'm not going to do a full ASCE 7 calculation on the wind loading of the structure, but yeah, just know that this is not going to do well in wind loading. Outside of that, I mean, we could talk about seismic loading, but even though I have a master's degree in structural engineering, I don't know a lick about that. So we're not going to talk about that. I think that does it in terms of the structural issues, though. I guess the foundation, I do have some concerns about the foundation, too. This could easily crack and break under loading, say if there's differential settlement of the soils. So by that I mean, right now, my gingerbread house is on my nice flat kitchen table. My kitchen table isn't going anywhere. It's not moving. But when you build something, the foundation, that being on the ground, your soils can consolidate over time and slowly move and shift over time. Meaning that this might not be fully flat. Maybe this corner is kind of supported, but maybe somewhere is not as well supported. Now, say if we have this scenario and I push down, look at how much that bends. That's not something you want. And so, point being is that this could very much move, settle, and shift over time as the life of the gingerbread house continues. So that's another item there that has me a little worried. I guess all in all to say, this home sucks. In terms of structural rigidity, ability to resist the elements over a long term, and do anything that would be useful to me as a structural engineer, this home does not pass. Our theory of whether or not gingerbread houses would be a long-term solution for the American housing crisis has shown to be a failure. We will not be able to use these as a long-term solution in order to reduce the pricing of homes. I wish I could provide you a better report as to what this could do for us, but as a licensed professional in both the engineering trades and the residential builders trade, I need to be honest and straightforward with you that this will not meet our needs long term as Americans. So yeah, I think that about sums it up. Maybe you are someone who also has insight as a building professional, maybe from a structural perspective or exterior envelope perspective like me, or maybe you have some electrical background, mechanical, plumbing. Let me know any other issues that you might see with this home. Otherwise, please like this video if you enjoyed it. Leave a comment as to other potential solutions to the American housing crisis outside of gingerbread homes, and maybe we can review those as well. Perhaps we'll look at a Lego house, who knows. Be sure to tell your friends and grandma about this channel, and yeah, I think that's all I got for you for this one. So thanks a bunch. Take care.